This question says the figure shows the cross section of outer wall of a house built in a hill resort to keep the house insulated from freezing temperature outside. The wall consists of teak wood of thickness L1 and brick of thickness L2, sandwiching two layers of unknown material with identical thermal conductivities and thickness. The thermal conductivity of teak wood is K1 and that of the brick is 5K1. This should be K1, right? Heat conduction through the wall has reached a steady state with the temperature of the surfaces being known. T1, T2, T5 are given. What is the interface temperature T3 and T4? That we have to calculate. If I represent this circuit with an electrical equivalent network, I can say there are four resistances. Those are in parallel series, right? These are the four resistors R1, R2, R3 and R4. R1, R2, R3 and R4. The temperature difference across them across R1 is T1 minus T2, R2 is T2 minus T3.
So R2 and R3 will be the same, no?
Yes, let us calculate that. We will calculate it. It is T3, T4 and this is T5. R2 and R4 both are same because they are the same material, same thickness, same area cross section.
R2 and R3.
R2 and R3, yes. So R2 is equal to R3. Let us assume this to be R. And what is R4? R1 is equal to, what is R1? R1 is equal to L1 divided by K1A. And R4 is equal to L2 divided by K2A, right? Now L2 is equal to 5L1 and K2 is equal to 5K2, 5K1. So I think you will find that R4 is equal to R1 also. Right? So R4 equal to R1, let us assume it to be R prime. Then I know that what is the current through this conductor. If this current is I, throughout this wall, the current is I everywhere because they are in series. So I can say what is the current. Current equal to T1 minus T5 divided by summation of R, right? R1, R2, R3, R4. So that should be T1 minus T5 is equal to 45 divided by 2 into R1 plus R prime, right? Also I can say current is equal to these two temperatures are known also, T2 and T1. So is it T1 minus T2 divided by R1? So this is 5 divided by R prime. If I equate this, I can find a relation of R and R prime. That will give me 45 by 2R plus R prime should be equal to 5 divided by R prime. So 9R prime is equal to 2R plus 2R prime. Right? So 7R prime is equal to 2R. That is another equation that I have got. I have to find the temperatures of T4 and T3. So look, I can say that the current also can be written as T2 minus T3 divided by R2. The potential difference across this R2 resistors is T2 minus T3, right? So T2 minus T3, T2 is known minus T3 is unknown, divided by R2 is R, right? So that is equal to 5 by R prime. 5 by R prime. R prime is equal to 2R by 7, right? R prime is equal to 2R by 7. So then RR gets cancelled out. 35 by 2, 17.5. So T3 is equal to 2.5. Also you can say I is equal to T3 minus T4 divided by R2, right? And T3 I know 2.5 minus T4, and R2 is equal to R, and that is the same as 5 by 2R by 7, right? So you can see that it is also 17.5. So T4 is equal to 2.5 minus 17.5, which is minus 15 degrees Celsius, right? So these two are the answers of these questions, T3 and T4. Just check what I have done. It is a simple electrical network. I have converted it into electrical network, and then I can solve a simple series circuit. Anyone have any doubt in this particular solution?
No.
Yes.
So in this question, I so the next one. So I think the one rod is missing here.
Yes, but you can go with the network. So you can have two rods instead of three of X. Two rods are there of X, three rods of there are in Y.
So I'm getting TB equal to 30 and TC and TD 20.
Yes.
So C and D will be equithermal points, just like the balanced Wheatstone.
Yes, yes. Good. So instead of three, you make it two. Right? Because in the diagram, one rod is missing. So two rods of material X and three rods of material Y are connected as shown in figure. All the rods are identical in length and cross section. If the end A is maintained at 60 degree and junction E is maintained at 10 degree, calculate the temperatures at B, C and D. Now we can draw an electrical equivalent network of this one, which gives us this circuit. A resistance, another resistance, another resistance, the resistance. So these five resistors are there, and they are connected with a battery where the potential difference is, how much is the potential difference? Can you tell me?
50.
50. 60 minus 10, right? So this point A is at 60 degrees Celsius, and this point E is at 10 degrees Celsius. I have to find the temperatures at B, C and D. These are R Y, and these are Rx. What is Rx? L by K, L by 0.95 A, and Ry is equal to L by 0.46 A. Right? So can I say Ry is equal to double of Rx?
Yes.
So if I say Rx equal to R, Ry is equal to 2R. Right? So Ry is equal to 2R, Rx equal to R. Let us assume Rx equal to R. And these are 2R, 2R, and 2R. So what is the R equivalent of this circuit? Can I calculate? R and 2R and 2R. These two are in series, these two are in series, but together they are in parallel and series in with 2R.
R, I think.
So 2R plus 2R into 4R divided by 2R plus 4R. Can I use this equation? Have you got what I have written here? Right? So that is equal to 4R by 3. Right? 4R by 3 plus 2R. So it is 10R by 3. Right? So if I say this current is I, then this current I should be equal to 50 divided by R equivalent. Right? And that is equal to 15 by R. Now can I write that TA minus TB divided by 2R, that is equal to I, which is 15 by R. So TA minus TB equal to 30. So what is TB? If TA equal to 60, it is equal to 30 degrees Celsius. Right? Similarly, if this temperature is 10 degrees Celsius and this is now 30, so can I say this current is I1 and this current is I2. So what is I1? I1 is equal to 30 minus 10 divided by 2R, right? So 10 by R. And also I1 is equal to TB minus TC by R. TB minus TC by R. So RR gets cancelled out. So what is TC? TC equal to TB minus 10 is equal to 20 degrees Celsius. And what is I2? I2 is equal to 30 minus 10 divided by 4R, 5 by R. That is also equal to TB minus TD divided by 2R. Right? So TD is also equal to 20 degrees Celsius. These are the answers of this question. Move to the next question. It's also taken from a JEE advanced question. A composite block made of slabs A, B, C, D, E of different thermal conductivities and sizes are shown in figure. Slabs are of the same width. Which option is correct? Have I given this as your homework?
No, sir.
No. Alright. Can you just try this question? A multi options correct type question is this. So this block is made up of A, B, C, D, E, these slabs, right? The width are same. If I try to draw the blocks, this is block A, block B, and block D. Right, like this. And you can see their widths are same. So at the back, their depths, these are the same. right? Like this.
Sir, only A is the answer.
Yes, let us check.
A is the answer.
If the heat is flowing through this phase, if the heat is flowing through this phase, let us assume this phase has a weight W. Then always remember that the resistance formula. What is the resistance formula? Heat resistance formula, do you remember?
L by Ka.
L by Ka. This L is measured along the current, A is measured perpendicular to the current, right? So if this heat is flowing through this slab A, then which length I will take to be L?
Along x-axis.
This is along x-axis, this L, this length L I will take, right? So the resistance Ra is equal to L divided by K into A, and what is K is given 2K, and area is what area I will take? Can you tell me what should be my area here? Through which area current is crossing?
That cross-sectional area.
Cross section area what? It should be L into W or not?
Yes, sir.
So 1 by 2K omega W is the Ra. Similarly, RB. What should be the length of RB? Can you tell me? Yes?
4L, 4L, 4L.
4L.
Yes, 4L by 3K into
3K into what area I will take?
5L omega. Yeah, 5L W. Yeah,
Yes?
4L W.
4W.
It's not 4LW. It's L into W. Can you see the heat is crossing perpendicular to the heat current? Which area I should take? Only this area or not?
Yes, sir, yes.
So what is this area? L into W, right? 4 divided by 12 kW. What is RC? For C, what should be my length?
4L.
4L.
4L divided by 4K. And what is area?
Area will be 12 omega. 12 W.
2LW.
2LW. Right? So it is 1 by KW. 2KW. And what is RD? Length is 4L divided by 5K. What is the area? It is the same thing as LW. So 4 divided by 5KW. And what is RE? What is the length for E?
L by 6K into 4L. L by 6K into LW.
L by 6K into
LW. 4LW.
4LW. Yes, I think this area also I have taken wrong. L by 2K
Yes, sir. That will also be then 4L.
4LW. 4LW. So that should be
8.
8KW. And that is also 4LW. Right? This length is 4L, not L. This length is 4L.
And so in RB, you have written 4 by 12 kW. That will be 4 by 3 kW.
It's 1 by 12 kW. Sorry, 4 by 3 KLW. Right? Yes,
By
yes,
3
yes,
only.
yes. 4 by 3 kW. Yes, so calculation mistakes are there. 4 by 3 kW. And this is correct. This is okay. And this will be 24 kW. Let us assume this to be R. Then this will be what?
3R. Sorry,
3R.
1 R by 3. R by
3R. 3R.
Shouldn't
This
be
is
R
R.
by.
This should be 3R.
Yes, sir, yes.
Right? And that would be how much it is? This will be 32R.
32.
Yes.
This will be 12R.
12R.
This will be 96 by 5R. Right? How the circuit
So
look?
RB, RC, RD in parallel and this will
Yes. How the electrical circuits it goes on? You can see that first the circuit comes on A. So this will be resistance RA. Then this current is divided in three parts: RB, RC, and RD. Then again it comes out of E. A, B, C, D, E. Right? This is the electrical circuit. Now, what is current here should be the same current here,
Yes, sir. So A is taken.
right? So, current A and E are the same. Option A is a correct choice.
So then B will be wrong.
So, this current is I, this current is I, right? These currents are different, but the sum of these currents are also I. Heat flow through E is maximum. Look, this current at E and A are the same, and all these currents are less than I, yes or no?
Yes, sir.
So I can say that heat current at E is maximum,
So
and
A is also same as
A
E only.
is also same, yes, but both of them are maximum, right? So A and E both are same and they both are maximum. Temperature difference across E is smallest. For that, I know that temperature difference across A is 3 IR and E is I into R. So A is more than E. But what will be the temperature difference across B, C and D? That I
The
have
same.
to calculate.
The B, C, and D will be individually same.
Yes, but what will be that temperature difference? It may be less than I into R.
Yes, sir.
Right? So for that, I have to find the R equivalent of BCD. Right? 1 by R equivalent. Okay, let us first calculate the equivalent of B and D. 1 by R, B and D is equal to 1 by 32R plus 1 by plus 5 by 96R.
So
Right?
it will be 96 by 7, 96 by 8.
Yes. So it is 3 and 3, 8 by 96R.
The 12 are only.
Yes.
12 hour.
So
Yes.
RBD is equal to 12R. RC is also 12R. So can I say RBCD is equal to 6R?
Yes, sir.
So it is the maximum, I think. The temperature difference across BCD is 6 IR.
It's
Across
maximum.
A is 3 IR and E is I into R. So E is smallest. Yes or no? What is heat flow through C is equal to heat flow through B plus D. Is that correct or wrong?
No, sir.
How you can say? Heat flow through BA plus D means current through B plus current through D. Current through B plus current through D and current through C, they are the same because look, if I equivalently replace B and D with a resistance, that will be 12R.
Yes, yes.
So
yes.
is that equal to RC or not?
Yes, sir. Yes, sir. It is.
So if RC and B plus D are same, then current flowing through C and current flowing through B plus D should be the same.
Yes, sir.
So all the four options are correct in this question.
So re-explain for the last part once.
Last part, you can replace this parallel three circuits as two parallel circuits. One is having resistance RC, another is having a resistance RB plus RD. Yes or no? Are they same? RBD and RC?
Yes, sir.
So whatever is the current flowing through RC, that should flowing through B plus D?
Yes, the same current.
Same current. So that is the option C. Have we done this one?
No, sir.
Also JEE advanced question. Three rods of identical cross section area made from the same metal form the sides of an isosceles triangle ABC. Right angle at B. Points A and B are maintained at T and root 2T temperatures respectively. In the steady state, the temperature of the point C is Tc, assuming that only heat conduction takes place. What is Tc by T? Look, where is my battery connected? Between A and B? Yes or no? There is one resistance like this, another resistance like this. Is this the electrical network? The lengths are like this. So if RAB is equal to RBC is equal to R, then what is RAC? Is it root 2R? Because resistance is proportional to length when K and A are constant. Right? If this temperature is theta, can I say these two currents are same? Yes or no? These two resistors are in series. Right? So what is current between A and C? Can you tell me what is current in between A and C?
T minus theta by root 2.
T minus theta by root 2R. This is T. This is root 2T. And is that same current flowing between C and B? What is this current?
The root 2t minus theta by r.
Or theta minus root 2T by R. Look the flow direction.
Yes, it is.
Now it's very simple to find theta. T minus theta is root 2 theta minus 2T. So theta is equal to 3T by root 2 plus 1. Option B is correct. Now this question says a hollow spherical ball of inner radius A and outer radius 2A is made of uniform material of constant thermal conductivity K. Temperature within the ball is 2 T naught and outside is T naught. What is the rate at which heat flows in steady state and the temperature at R equal to 3A by 2? Just try to do it.
So is the rate 4 pi KAT?
Yes, what's the rate?
The 4 pi KAT.
4 pi K A T. It may be 1 second. How do I solve this?
So for the second part, so we need to consider an arbitrary element and then we have to integrate.
Yes, look. Here the heat flow is in radial direction. Can you see that? Suppose I have taken a very small cross section of length dx, of length dr. Okay, 1 second. So this is A, this is 2A, and let me assume a small cross section, small hollow shell whose radius is R and it is lying in between R and dr. Thickness is dr. Why I have taken a differential element or a infinitesimally small thickness of this element. The reason is, if you see that heat flow here is taking place from inside to
Area is
outside.
changing.
It is not constant.
Yes, area is changing with R.
Sectional area is not constant, so heat will also be not constant.
Area is changing, right? You can see the radial flow here. This flow is happening for an area of 4 pi r square, through an area of 4 pi r square, right? As r is changing, so the area is also changing, area of through which the heat is flowing. So can I write the thermal or heat resistance with this equation? Do you know the integration? What is that heat resistance? Have I discussed that? Heat resistance is equal to integral of what? Dx by k.
Yes, sir. DL by K.
Yes, sir.
Right? If k and a are variable, then it is dx by k, integral of that. So I will write here, what is dx? Dx is the thickness or distance along the direction of heat flow. So what is the along the direction of heat flow? The current is flowing for this
dr.
shell, dr. Right? K is constant, and what is the area perpendicular to the current flow? Which area I will take perpendicular to the
4
current
pi
flow?
R square.
4 pi r square. If you integrate from A2 to A, you should find the total heat resistance for this circuit or for this material. So that will be 1 by 4 pi k into minus 1 by r. Put a limit of A to 2A, you will find it is 1 by 2A. So 1 by 8 pi k into A, that will be the thermal resistance. Then what will be the heat current? Heat current is the temperature difference 2 T naught minus T naught divided by the heat resistance. So that is 8 pi Ka into T naught. That will be the answer to the first question. Have you got this one, what I have done?
Yes, sir.
Now, for the second part of the question, you can assume these two cross sections, inner radius and outer radius. Can I say a potential difference is applied in between them, which is 2 T naught minus T. A potential difference is applied between them, which is 2 T naught minus T. And there is a resistance from this point to this point. And what is this resistance? It is that resistance.
Yes,
Yes or
sir.
no? But I can divide this resistance into two parts, two series resistors, like this.
So why have we divided it?
Because second part I have to find the temperature at R equal to 3A by 2. So let us assume this point is R equal to 3A by 2. Right? And the temperature at this point is theta. This point has a temperature 2 T naught. This point has a temperature T naught. Is that current same throughout this?
Yes, sir.
So why are you assuming the resistors like this?
Because these resistors are continuous. Now, from here to here current is flowing. So these are in series resistors. If I say what is the total resistance from here to here, can you integrate it from A to 3A by 2 and plus 3A by 2 to 2A?
But there are infinitely number of registers.
Yes, but all of them are connected in between this shell is connection of all these infinite resistors from here to here.
Means R1 means that the sum of that or all
Yes,
resistance
yes, yes.
between that points.
Yes, I am talking about R1 resistance between this resistance between this inner radius and 3A by 2.
Okay, sir, got it.
Right? R1 is the heat resistance in between A to 3A by 2. Have you got it?
Yes, sir. So
And-
minimum two resistance we have to consider. That's why it is 2.
Yes. And R2, I can say heat resistance between 3A by 2 to 2A. Why I have taken R1? I have to find R1, otherwise I cannot find theta. Because I can say from this circuit that 2T naught minus theta divided by R1, is it the same current I that I have
Yes.
found here? So I know what is I have to calculate what is R1. And what is R1? Can I use the same expression only in case of 2A as the upper limit? Now my limit should be 3A by 2. Yes or no? From A to 3A by 2. Is that R1 or not? Have you got this one?
Yes, sir.
Calculate what is R1 and then I can find what is theta.
current will be that only 8 by K at T0.
Current is same. So if I solve it, do we get this one 4 pi k into 1 by a minus 2 by 3a. So I think 1 by 3a.
So 1 by 12, yes. 1 by 12 pi k.
So 1 by 12 pi k a. Right? So from there I can now find what is theta. Theta is equal to 2t naught minus I into R1. Right? So I is 8 pi ka t naught and R1 is 1 by 12 pi ka. Right? So 8 t naught by 12 means 8 t naught by 12 means 4 t naught by 3.
2 T naught by 3.
So 2 t naught by 3 should be the
Sir,
answer.
no, sir. Sir, it will be 2 T naught by 3. 2 T naught minus 2 T
Yes,
naught.
2 t naught minus 2 t naught by 3. So that will be 4 t naught by 3.
So we could have solved this part by integration also.
Yes. Is this clear to all of you?
Yes, sir.
Okay, next is freezing of lake. Probably you have seen that in winter season, a very cold temperature zones where the temperature actually lies below 0 degrees Celsius even. In those places, lake actually starts freezing. Right? So how does that happen? That we have to understand mathematically also. Let us assume that this is a lake. This is a lake, and the temperature of air is at below 0 degrees Celsius, right? It is not 0 degrees Celsius. Atmospheric temperature falls below 0 degrees Celsius. Okay, so let us assume it to be minus theta degrees Celsius. This is minus theta. Temperature of air is minus theta degrees Celsius. Right? And already this much of ice has been formed. Ice starts forming from the top level, from the top, because this is close to the atmosphere. So it first releases temperature, heat to atmosphere. Atmosphere takes heat from this water. Let us assume that x thickness of ice has already been formed. Another dx thickness of ice is forming in a time dt. Right? So in time t already x thickness has been formed, and next dt time this dx thickness of ice will form. Right? So when this ice will form, then this water, which was earlier water here of this much volume, this water actually loses heat, releases heat, and this heat is going to the atmosphere through this ice. Yes or no? So this ice layer is now like a conducting layer for this heat transfer, right? And what is the rate of this heat transfer that I can calculate? Okay, let us understand. This is written at time t, thickness of ice surface is x. and air temperature is minus theta. Temperature of water in contact is 0 degree. This water is at 0 degree Celsius because when water is converted into ice, the temperature of water is at 0 degree Celsius. Right? So when this water releases heat, then what is dq by dt? Dq by dt is equal to K. K is the thermal conductivity of ice. Right? Cross section area of this lake is A, and the temperature difference is theta divided by this thickness is x. Right? So dq by dt is this one. Can you understand this equation? Yes or no? Is that equation okay to you? From Fourier's law of heat conduction?
Yes.
Yes. Now this much amount of heat, can I say, as water releases this much amount of heat, so this is equal to mass of the water into the latent heat of fusion of ice? Yes or no? So what is mass of this water? It is the density multiplied by volume. Right? So this mass of this water is equal to density of the water into volume. What is volume? This is dx into A. Yes or no? So m into L is the dq, which is rho A dx into L. So I can say k into A, theta by x dt equal to rho A dx into L. Then what is dt? I can find this expression. If you integrate, the total time will come to half rho L by k theta into x square. Right? So this is the expression for the time taken. And thermal conductivity of ice is very small. Right? Ice is not a good conductor of heat. As ice is not a good conductor of heat, you can see that this time is very large. Right? So until this entire winter season has gone, this water will not be able to freeze completely. That is why just below this ice layer, right, water is still in a liquid state. Have you got this mathematical equation? I think that was all about conduction process. We have done so many mathematical calculations also along with the theory part. Now let us start what is convection. Not much there is in your syllabus about convection. Will not discuss much about convection. You can understand that convection is basically due to the difference of the density level of water. As we heat, the temperature of the body which is in direct contact with the source, right, or closer to the source, will increase and its density decreases, making it lighter, and it will go up, and the heavier or the liquids having less temperature again comes back down, and this cycle goes on. Right? This is known as convection. This is actually a natural convection process, right? And in Earth, most of the heat is transferred due to convection. Convection requires a medium. In this process, in which heat is transferred from one place to another by actual movement of heated substance. Usually it is seen in fluid. As I have told you that solids, particles cannot be displaced, they can only vibrate. The type of convection which results from difference in densities is known as natural convection, right? However, if a heated fluid is forced to move by a blower or fan or pump, this process is forced convection, right? So sometimes you can see that in order to cool something rapidly, we blow air, right? And that is a forced convection. Blow air means you are actually displacing the hot air particles by blowing air. So that is forced convection. But this convection, which happens due to the difference of densities, is natural convection. The rate of heat convection from an object is proportional to the temperature difference between the object and convective fluid and area of contact, right? So dq by dt is equal to h into a into delta theta, right? So the rate of heat convection from an object is proportional to the temperature difference between the object and convective fluid.
So what is H?
H is a constant of proportionality, right? It depends on material or the fluid which you are using, right? So if this is a body and a fluid is passing through it, right? Then fluid will always take heat from this body, right? So this uh, dq by dt, at which rate the fluid is taking heat from this body by convection method, depends on the area of the contact of the fluid and the body, and also depends on the temperature difference between the fluid temperature is suppose lower than the body temperature, then fluid will take up heat from the body, and H represents the constant of proportionality. It depends on the property of the fluid. Heat propagation via convection, temperature gradient exists in vertical direction, not in horizontal direction, right? So I am talking about, this is talking about natural convection.
Sir, in that equation, where is that gradient term?
Gradient means the delta theta. It is talking about delta theta. Heat difference. It's not a gradient that d theta by dx. D theta by dx is also there if you talk about this y direction. Basically, if you think about this heat conduction, then this is a different layer in y direction heat convection. This temperature is theta 1, this layer has a temperature theta 2, this layer has a temperature theta 3, like this, right? So that is why heat can be transferred from one layer to another layer by this convection method, right? But that will exist in vertical direction for natural convection. It is talking about natural convection, right? And most of the heat transfer in earth is by convection method. Again, you don't have to focus much on this convection topic because it is not in your syllabus. The mathematical expressions are not there, right? So you can leave it, right? Only you have to understand the basics of convection. What is that?